I'm quickly going to do exercise 13. You guys can just watch me while I do it. We're very quick. Exercise 13. But we must start with a new section today. So I don't want to carry on with this. So I'm just going to do it very fast. Okay, and then we can mark obviously. So you have to rationalize all of these denominators. The first four, the first six just had one term in the denominator. So for the first one, it was 1 over root 3. And you have to multiply the top and the bottom by root 3. So that answer is root 3 over 3, yes? There we go, root 3 over 3. Okay, that is number 1. I'll do number 2 just next to it. Number 2 was similar, but it was 3 over root 3. Again, you just have one term in the denominator, so you multiply the top and bottom by the surd that you have in that denominator. All right, so by root 3 again, so you have 3 root 3 over 3. And now guys, I think someone asked me yesterday if you have to cancel out if you can. Yes, all right, so that 3 and that 3, they will cancel out, and you are left with just root 3. And that's the nice thing about these questions is you can actually check on the calculator, right? You can just type it in on the calculator. The calculator always gives the answer with a rational denominator. So it will always give the correct answer. So you can check like that. Okay, number 3 quickly was root 2 over root 3. So you times by root 3 again, top and bottom. So here you're going to get root 6 over 3. Now guys, can you cancel anything out there? No, hey, you can't say, oh, there's a 6 in that root, I'm going to cancel it out with that 3. You can't do that, okay? The 6 in the root is not the same as the number 6. All right, so you can't actually cancel anything out there. That is the simplest answer. So number 4 was 6 over root 2. So now you times the top and the bottom by root 2. You get 6 root 2 over 2. And now that you can actually cancel, right? 2 goes into itself once and into 6 3 times, or you can just say 6 divided by 2 is 3. So the answer here is 3 root 2. Okay, how's it looking so far, guys? Good. Right, all fine. Number 5 was 1 plus root 3 all over root 3. So you still only have one term in the denominator, so you just put brackets around those 2 terms at the top, because now you're going to have to multiply both of those terms by root 3. Multiply the bottom by root 3 as well. So we're getting 1 times root 3 is root 3, plus root 3 times root 3 is 3. It's increasing the whole time. Sorry. And then here you are getting root 3 times root 3 is just 3. Now guys, here you're not actually able to cancel out, right? Because you have 2 terms at the top. So if you just say 3 and 3 cancel out, you've only divided one term at the top by the 3. You're supposed to divide both of them, which is why in that example that we did yesterday, we took out the common factor and then we could cancel. All right, because when you take that common factor out, you are dividing each term by that number. This is your final answer. You can't do anything else. Okay, if you cancel out those 3, you're going to lose them all. Okay, we're going to say -1 because something that's wrong. Okay, number 6. 4 plus root 2. And that is all over root 2. Again, you have one term in the denominator, so you times the top and the bottom by root 2. You get 4 root 2 plus 2 over 2. Now here you can cancel, right? First you have to take out a common factor of 2. So you're going to take out 2 there. And remember, when you take out a common factor, you divide each term by that. So it's going to be 2 root 2 plus 1, and then that is all over 2, and then those 2's you can cancel out. So you are left with 2 root 2 plus 1. And find that one. Okay, number 7, we're almost there, guys. Now, this was the first one that had 2 terms in the denominator. All the previous ones just had 1. So when you have 2 terms in the denominator, you need to multiply the top and the bottom by the same 2 terms that you have in the denominator, but with a different sign in between them. And guys, I didn't tell you this yesterday, but it has a name, right? The same 2 terms, but a different sign. We actually call that the conjugate. So you can add that there. You don't have to know it really, but just in case you maybe see that word and you know what that means. Conjugate literally means the same 2 terms with a different sign in between it. So this is the conjugate of the denominator. So that is what we do. Same terms, different sign. Okay, so at the top, root 3 times root 3 is 3, and then plus root 3, what did we get at the top? At the bottom, you're going to FOIL out, right? So you're going to say root 3 times root 3 is 3. You're going to do your outers, your inners, and then your last. And remember, I told you yesterday, you can just draw a line through those 2 terms to show that they can cancel out. Root 3 minus root 3 is 0. So you're left with 3 plus root 3 over 2. Yes? Okay, and that is the answer. I'm going to do 8 here next to it quickly. Almost there. This is the second last one. So 1 plus root 2 over 1 minus root 2. You see we have 2 terms in the denominator, so we multiply the top and the bottom by the conjugate of the denominator. We just learned that word now, which is the same 2 terms but a different sign in between them. And we just put brackets around those terms to remember that we must FOIL these out now. Okay, so we are going to get the following. Plus, so 1 times 1, then we do the outers, which is root 2. We do the inners, which is again root 2. And we do the lasts. If I multiply those together, that's 2. All over. I'm going to FOIL here again. 1 times 1 again is 1. Outers is plus root 2. Inners is minus root 2. And lasts is now minus 2. And I'm very worried that you're going to see that and you're going to be like, oh, I can just cancel like everything out. Please don't do that. You may not cancel out if you have more than 1 term at the top or the bottom. Okay, so even though, because it kind of looks like you can, hey, it's even like nicely lined up here. It looks so convenient, but it's very much easy. You can't cancel those out. You have to simplify. So we have 1 plus 2, which is 3. And root 2 plus root 2 is 2 root 2. Okay, at the bottom, those thirds are going to go away. And we have 1 minus 2, which is negative 1. Now guys, I'm actually not going to leave it like that, right? Because if you are dividing something by negative 1, what does that mean? What happens when you divide something by negative 1? The signs just change, right? So good, so I can actually just write this as negative 3 minus 2 root 2. So that is your final answer in that case. Unfortunately, you can't do the factors. If it was a minus 2, then sure. Okay, then you could just put that minus in front. But because it's a minus 1, those 2 signs at the top just cut it. So just put it with that. So I have to do negative number 9. Can I just say what the answer is? Okay, number 9. What topic is this topic? 1, exercise 13. Let me just check. If any of you want me to just check your answers, maybe not. Oh, that has a good answer. Well, maybe I'll just not do it. This has a lot of terms, more terms than any of the others. Okay. Yes, yeah, we'll just leave 1 after that, yeah. Okay, sorry, I saw the answer now to this, and it's actually a bit complicated. because we're working with different surds at the top and the bottom. So 1 plus root 3 over 3 minus root 2. Okay, we have two terms in the denominator. We're timesing the top and bottom by 3 plus root 2. 3 plus root 2, there we go. We put our brackets. Okay, I'm going to FOIL out very quickly, but it's with the foiling out, because we have different surds, right? We're going to get different types of terms here. So 1 times 3 is 3. Then we do the outers, which is root 2. Then we do the inners, which is 3 root 3. And now for the last, it's not the same, so it's like we have in the other questions, right? It's root 3 times root 2. And that is actually root 6. Right? If you have root 3 times root 2, because they have the same root, the same surd, you can put that together under 1 square root and times those numbers together. You can't do that if it was a plus, right? It's only when it's times. So that's where that root 6 comes from. And then at the bottom, 3 times 3 is 9. That's going to give you plus 3 root 2. The inners is going to give you minus 3 root 2. And when you do your last, you're going to get minus 4. Those two are cancelling out. What's 9 minus 4? 5. And at the top, I have no like terms. Right? It's a bit annoying. None of these I can actually add together. So I need to write all 4 terms. But that's okay. All right, it's a possible answer. But that is then all over 5. Okay, I've copied some notes, guys. I'm now going to hand out. We are doing analytical geometry. I don't know how you guys felt about that last year. I know. Today we are just revising the grade 10 stuff. We're not doing anything new today. And possibly even tomorrow we'll still just be revising. So I want you guys to practice the grade 10 stuff. Very well. Okay, guys. Okay, guys, let's do some highlighting, some underlining. I didn't think anyone would be very much in the mood to like copy all of this stuff down. Okay, guys. So we are just going to go through these headings. These are all things that we were supposed to do last year. Now I know last year it was 1 day in, 1 day out. I don't know, maybe you weren't involved in the actual. So I printed this summary for you guys with all of the topics and all of the formulas on basically a page and a half. So the first one that you must please underline is the distance between 2 points, the distance formula. Guys, all of these formulas you have to memorize. So we're not going to give them to you. So if you don't know these formulas, obviously you're going to struggle when you're actually doing the work. So I'm not really going to look at all of this because this is kind of like a proof. It's showing you where the formula is coming from. You can look at that if you want. It's not really important. What is important is this formula here. All right, the distance formula. You have to know that formula, you have to be able to apply that. I'm going to practice it with you now. Now, x of b and x of a, and then y of b and y of a, those are referring to the actual coordinates. Remember, analytical geometry, it's the other name for analytical geometry is actually coordinate geometry, because you're working on the Cartesian plane with points with x and y values. Okay, the other geometry that we're going to do later on in the year, circle geometry, that is Euclidean geometry, where it's just a shape. It's not necessarily on the Cartesian plane. So this is saying, guys, that in the distance formula, if you need to find the distance between points A and B, you can add that there. Distance between A and B, but they can also phrase it differently. They can also ask you for the length of the line AB, which is connecting points A and B. So you'll use the same formula for both. So or the length of line AB. So what you're going to do is you're going to take the square root of everything that's under the square root. The one x value minus the other x value, right? The x value for one point minus the x value of the other point, you square that, plus the y value of the 1 point minus the y value of the other. Squared again. Okay, so you always subtract the coordinates, but then in between the two brackets there's a plus. People often get that wrong. They get confused with where's the minus, where's the plus. Okay, we won't do an example with this now. So that's the first formula that you have to know. Yes. It doesn't have to be. So you can decide you want to do A first and then B, but if you're doing A minus B, you must do Y. For the Y is also A minus B. So you have to keep that order the same, but you can decide. Right, that's for the midpoint. This is a nice easy one that people usually get full marks for. The midpoint of the line segment. Right, that is the formula. Now guys, it's important that you don't mix up your M. For midpoint, we use the capital M. And for gradient, we use the lowercase m. Okay, that is how you need to use them. So the midpoint, now the midpoint is a point. That's why we're putting brackets around it, right? Because this is going to give us an actual point, coordinates of a point. So when you're working it out, you have to put your brackets there as well. You take the two x values, you add them together, you divide that by 2. Then you take the two y values, add those together, divide by 2. Order doesn't matter here, guys, because we're adding. Okay, so you can say, you can take A plus B or B plus A, doesn't have to be the same answer. So that is a nice easy one. Okay, that's usually a 2-mark question. You usually get a mark for the X value and a mark for the B, the Y value. Okay, now gradient of a line segment. Now guys, you did straight lines in grade 9, right? And then last year you did straight line again, but then you added some graphs. Now, straight lines and straight line equations, it also comes up in analytical geometry. Okay, so the gradient of a line segment, I've summarized some things here. It's saying that the gradient of a line segment describes the slope of the line. We remember that if the gradient is positive, the line is increasing. All right, so this is an increasing line. So this has a gradient that is bigger than 0, that is positive. It's literally going up. Right, so it has a positive gradient. A line that is decreasing like this, going down, will have a negative gradient. So like -2, the actual value of that gradient will be a negative number. Okay, and then you can also just put a bracket or highlight that. That is the formula that we use to find the gradient. Right, you're changing y over changing x. So you take your one y value minus the other value over the same first x value minus the other x value. Here, order is again important. So you can decide. You see here that I wrote two options. You can take the y value is b minus the y value is a, but then you have to use that same order for the x's. Or you can do a minus b, but then you must do a minus b at the bottom. So again, we'll practice this a bit now. There are some extra things that you need to know, guys. You need to know the term collinear. So just underline that. That isn't something that ever comes up when you're doing like graphs, all right? But they can ask you about collinear points. That means that they lie on the same line. Oops, line. Lie on the same line. So if you had, just say for example here, if you had a point there, that point was A, and you had a point there, those 2 points lie literally on the same line. Okay, so we would say that A and B are collinear. Okay, so if they're using that word to understand what that means, it means that they're lying on the same line. So now, guys, if there was a third point, right, if we're adding a C as well, if they now tell us that A, B, and C are collinear, that means that the gradient between A and B is not going to be the same as the gradient between B and C. It's the same line, right? So the gradient between A and B will have to be the same as the gradient between B and C, but that's also the same as the gradient between A and C, because they all lie on the same line, guys. The line has one gradient. So if multiple points are collinear, they will have the same gradient between all of those points. Okay, so that is what they're saying here. If A, B, and C are collinear, then the gradients between any two of the 3 points on the line will be the same. All right, so we can just underline that quickly. The gradient of AB will be equal to the gradient of B, will be equal to the gradient of AC. So sometimes they give you 3 points and they say, prove that these points are collinear. All right, so then you will do this calculation. All right, then you'll actually find those gradients. So I'm just going to make a little arrow to prove that these PTS points are collinear. That's what you will have to do. So I actually have to calculate the gradient of AB and calculate the gradient of B, and then see that they are equal. Next up, I'm sure you guys know this. If two lines are parallel, then they're going to have the same gradients, right? Then their gradients will be equal. So if they're asking you guys, prove that AB is parallel to CD, you're going to have to find the gradient of AB and find the gradient of CD and show that they are the same number. All right, so you can underline this, AB and CD over there. So this is what you will do to prove that AB is parallel to CD. Okay, then the last thing about gradients of straight lines is if two lines are perpendicular, then the product of their gradients will be equal to -1. Right, so if you have the gradient of the one line and you have the gradient of the other line, you then multiply them together and your answer is -1. That means that those lines are perpendicular. Okay, so perpendicular, remember, means that there's a 90-degree angle between them. So that's what they're saying here. If AB is perpendicular to CD, then this, you can use this as a formula actually. The gradient of AB times the gradient of CD is equal to -1. Sometimes they give you the one gradient and you need to find the other one. That's sort of another question that they can ask. So here, to prove that AB is perpendicular to CD, right, then that is what you would do. Find the gradient of AB, find the gradient of CD, times them together, and if your answer is -1, and you can say that they are perpendicular. Just one picture notes there. Yes, those two. Okay, guys, are you with me? Those three have some questions that they can ask you. All right, quickly, the equation of a straight line. Now, there are two formulas, right? When you were doing graphs, you probably learned the y equals mx plus c formula. But in analytical geometry, there is another formula. You guys learned this formula last year. Y minus y1 equals mx minus x1. I actually think this one is a nicer formula to use because it's quicker. All right, so I'll do an example so that you can see how it works. But we are going to use formula 2, right, when it comes to analytical geometry, and we can also actually use it when it comes to actually drawing the graphs and so on, but that's later in the year. Now, the important thing here is that your answer has to be written in the form y equals mx plus c. Okay, so, but it will be quick. Yeah, you'll see what I do. It's faster actually to find the equation using this formula than it is using the other one. Okay, now guys, what you're going to do is, let me see, is it actually summarized here? No. So I'm just going to write just underneath, step 1 would be to find the m value, which is the gradient, right? And we need that formula for gradient change in y over change in x. Okay, so that's going to be the first thing that you're going to do. And then step 2 is going to be to sub in a point. And we are going to sub it in where it says x1 and y1 in the formula. And then step 3 will just be to multiply out the brackets. Multiply out. Okay, if we go to the next page, this is something that I think people probably look at a lot, but it's actually not that bad. So I put the picture there for you so that you can see how it works. Finding the coordinates of the fourth vertex of a parallelogram, so the fourth point of a parallelogram. So guys, you can see that there are 2 dotted lines here, right? So these dotted lines are actually like a part of your working. So if the question here was saying that you have points A, B, and C, right? It's here on the side. Given A is -4, -3, right? Now guys, remember that how coordinates work is the first one is the x value and the next one is the y value. So -4 is in line with -4 on the x-axis and -3 on the y-axis, right? There's -1, -2, -3. So that's point A. Point B is -3, so -3 on the x-axis and 2 on the y-axis, -3, 2. And then C is 3, 4. So we go 1, 2, 3, and then 1, 2, 3, 4. Right, there we have point C. So only those 3 points are actually given. Okay, then they ask you to determine the coordinates of D if A, B, C, D is a parallelogram. Now guys, it's very important to note, and it is actually typed up there, so let's underline that. It is very important to note the order in which the vertices, the letters of those points of a parallelogram are mentioned in the name A, B, C, D. Because that is going to tell you where that point is going to be. Sometimes they ask for A, B, B, C, or A, D, C, D, or something, all right? The order in which those letters are, that is telling you the order in which the points are connected. So here you can see A, B, C, and then because the name of this parallelogram is A, B, C, D is going to have to be next and be connected to A. All right, so if it's A, B, C, D, where can I write it? I'm going to write here at the bottom, A, B, C, D. That means that D is connected . . 'Cause to the letter in front, to C, and then it's the last letter of the parallelogram, it will have to be connected to the first one as well. All right, so D is connected to C and A. Almost like it's in between C and A. Because there are some questions where the fourth point can be in different places. And then the name of that parallelogram will tell you where that point is placed. So you are going to do some examples in Alright, if you have the picture, it's actually really easy to just look at the picture and to just count. Okay? So if we have A, B, C, D, you just kind of on the picture, you just kind of eyeball it and you say, okay, D has to be here somewhere. All right? It doesn't have to be accurate. You just say, okay, A, B, C, D, you must be there somewhere. Right? A, B, C, somewhere there. Okay? Then you're going to look at the change. Now, if we're looking at the change from A to this point, it has to be the same as the change from B to C. Right? Can you see that? Now, what happens to the coordinates of B to get to the coordinates of C? Plus 6, right? From -3 to +3. We're looking at the x values. -3 to +3. Do we agree that that's plus 6? Okay, so the x value, we added 6 to it to go from B to C. So now we'll do the same thing here, right? We need to look at the x value of A and add 6 to it to get the x value of B. So the x value of A was -4. What's -4 plus 6? 2. There you get your x value. All right, if we're looking at the y values, the y value of B was 2. The y value of C is 4. What happens there? From 2 to 4, I'm just adding 2. So we would do the same with this y value to get that one. So this y value is -3. What's -3 plus 2? -1. Okay, so that is how you're going to find those coordinates, right? This is always just a 2-mark question. You don't have to show any words that you can just write the answer down. It will never have more than 2. 1 mark for x, 1 mark for y. Okay, even in matric finals, and they always ask a question like this every single year. Okay, we are going to practice. Let me just see. So this is a worksheet, a grade 10 revision worksheet. You ask for the length of A, coordinates of the midpoint. Yes, C, final coordinates of D such that A, B, C, D is a parallelogram. Calculate the gradient, and is it also a rectangle? Prove your answer. I'm just looking at the other questions here. I actually want to do number 5 with you. All right, so I'm going to do number 5 with you. Then I'm going to give you guys some to work on now if we have time at the end of the lesson, and we're going to do some more work tomorrow as well. Okay, on this stuff. So you can just write grade 10 revision worksheet. Okay, those are the 4 points that we have. So guys, what I always do is I actually just rewrite those 4 points. Okay, so that they're on the page so that I know what I'm working with. So now for 5A, they're asking us what is the gradient? The gradient is lowercase m of PQ. Okay, so if you want to specify that we're now calculating the gradient of PQ, you can write PQ like that as a little subscript. Okay, that's quite useful, especially if you have to calculate different gradients in one question. All right, then please label each gradient like that. But remember that gradient always change in y over change in x. Okay, so I'm going to write that down. You don't have to, you can just sub it in straight away, but I just want you guys to see that formula. So change in y over change in x. So now you can decide, do you want to start with point P or do you want to start with point Q? Doesn't matter, as long as you stick to the one that you're starting with. So let's say we're going to start with P. Okay, because we did write P. So we're going to take the y value of P minus the y value of Q, and then put that over the x value of P minus the x value of Q. Now guys, the biggest or the most common mistake here is that people want to do the x's first, right, at the top. So people swap the formula around. So to understand, because we're so used to x comes first, right? But in this formula, we have to do change in y over change in x. So what is the y value of P? -5, okay? -5 minus the y value of Q is 1 over the x value of P is -3 minus the y value of the x value, sorry, of Q, which is 5. Okay, so you take the one minus the other over the same first point minus the other one. Okay, now we need to simplify this. -5 minus 1 is -6 over -3 minus 5 is -8. Can I leave it like that? Firstly, a negative divided by negative is a positive, right? And 6 over 8, what's that? 3 over 4. Okay, so that is the final answer. But you don't have to show all of those steps. Okay, you actually don't have to write down the formula. You can if it helps. You don't have to. And then you don't have to show this like in between simplification steps. Okay, you can almost do this in your head. Or you can just type this into the calculator and write the answer. That's just fine. You don't have to do this stuff without using a calculator. You can use a calculator. Okay, we find that one. Just the gradient. Okay, for B, they're now asking for the length of PQ. So for the length, we need to use the distance formula. Okay, so we're going to take square root. I'm just going to write the formula out. The x value of P minus the x value of Q. I'm deciding to start with P and then minus Q from it. You can do it the other way around. Then you must square that plus second bracket. Y value of P minus Y value of Q, close bracket, squared. Okay, now we're going to sub those values in. So again, we're doing x value of P, which is -3, minus the x value of Q, which is 5, squaring that, plus open bracket, y value of P, which is -5, minus the y value of Q, which is 1, square that, or the square root there. And 36 over 100. All right, so you can type that in the calculator, guys, that's fine. But this is -8, and -8 squared is 64. That is -6 squared, which is 36. 64 plus 36 is 100, and the square root of 100 is 10. So that answer is 10 units. But you can type it in the calculator, guys, that's fine. Right? You don't have to spend time trying to actually work that out. Type it in. So the length of PQ is 10 units. Okay, let's look at C. Okay, M is the midpoint of RS. So midpoint, we're going to take the x value of R plus the x value of S and divide that by 2. Then we're going to do the same with the y values, right? We're going to take the y value of r plus the y value of s and divide that by 2. Okay, so the x value of r is 5. Now the x value of s is -1, so I'm just going to write -1, right? 5 plus -1 is the same as -1 over 2. Y value of r is -6 plus the y value of s is 2. That is also over 2. And again, this you can type into the calculator or you can just work it out in your head. So you have 5 minus 1, that's 4, divided by 2 is 2. So the x value of that midpoint is 2. And then for the y value of -6 plus 2, that's -4. So -4 divided by 2 is -2. That is the midpoint of Rx. So guys, basically all we've done so far is we've applied formulas, right? So all you need to actually know is you need to know those formulas and you need to be able to differentiate between what is an x value and what is a y value. Okay, then you'll be fine. So guys, English is your final exam also for like 10 years already. Question 3 is always an analytical geometry question. And they always start with questions like this. There's always a gradient question. And there's always a straight line equation question. There's always a midpoint or a length of the line question. Like they actually ask these quite basic questions at the beginning. So you can make up a lot of marks on them. Okay, then the last one in number 5 is D. Now this is saying, show that, I'm just going to write the question down. Show that PQ is perpendicular to RS. Now you need to remember the method when we have to do that, right? To show that two lines are perpendicular, you have to say, or you have to show that the gradient of the one to the gradient of PQ, which we already calculated, eh? We calculated that in A. So that was 3/4. We actually have that already. Multiplied by the gradient of the other line, so RS in this case, which we haven't calculated, so we're going to have to work that out, is equal to -1. Okay, we can show that and we can say that the lines are perpendicular. Okay, so I'm just going to write down here that the gradient of PQ we already calculated was 3/4. Now we must find the gradient of RS. And guys, please label those gradients. I can't tell you how many times I've marked tests and exams where it's just n equals this and n equals this, and then even worse, the two gradients are wrong, so you don't know what's happening. Okay, so if you just label as the gradient of PQ and the gradient of RS, that makes it much easier to follow than they are. Okay, just quickly, we're going back up to R and S. Those are the coordinates. So we're going to say change in Y. So we're going to do -6 minus 2 at the top. Over change in X, 5 minus -1. Right? When you are minusing, you need to minus the whole thing, even if it's negative. Okay, so I'm going to say at the top, change in Y is -6 minus 2 over 5 minus -1. You can write that as 5 plus 1, so it is what you want to. R was 5 -6, and S is -1, 2. Okay, so I'm doing change in Y, that one minus that one, over that one minus that one. Again, you can type that into the calculator straight away if you want to. But at the top, you're getting -8, and at the bottom, you're getting +6. Right? And when I simplify that, that is -4/3. And that's the gradient of Rx. Remember, we're trying to show that PQ is perpendicular to Rx, so now I must actually find the product. And if it's -1, then I can say that it's perpendicular. How are you going to say? Therefore, the gradient of PQ multiplied by the gradient of RS, right, that's equal to what is the gradient of PQ? X 3 over 4. And the gradient of Rx was negative 4 over 3. Now what's going to happen here, guys? The 3's are going to cancel off. And the 4 at the bottom is going to cancel out the 4 at the top. So what's left if everything has been cancelled out? A negative, right? Negative 1. Remember, that's what we did when we worked with those exponential equations, right? We raised both powers to an exponent that will turn it into 1. Remember? So it's very similar to that. So are these two lines perpendicular? The product of the gradients is negative 1. So therefore, PQ is perpendicular R. Okay, I'm going to just give you one question for homework. Two questions, but by two questions I mean A and B. All right, so all you're doing for homework for tomorrow is 1A and 1B. Do it now, guys. You have 5 minutes. It's finding the length and finding the midpoint. All right? Yes, sorry. You can go now and just try to do it. Sorry, that took longer than I thought it was going to. Let me just stop recording.